Alright guys, today we're working on 6.3a and b. A is just a review again, performing operations on functions as addition, subtraction, and multiplication, which in this case is called scalar multiplication. We practiced this when we came into 6.2a and did very similar operations. But more specifically today we're working on 6.3b, which is performing function composition. That's I-O-N. Okay, so we've got a function down here. If you would please just try to graph this to the best of your ability. We've got a straight line that goes through the point -2, 2, and then -3, 0, and keeps on going to the left. It makes a quadratic curve in the middle with our vertex down 2 points from the origin, over 1, up 1, over 1, up 1, and then connects back to your -2, +2. And then at 1, -1 is another horizontal line that goes to the right. Okay, so this is our f function. Our g function is g of x equals 2x. Our h function is h of x equals x squared. If you would please just make sure you go ahead and copy this down, at least the first couple, so that way we can have space and then you can copy the next couple down. Alright, so when we're asked to find function composition, that'll be given a problem that looks something like, kind of like this. And when I was always in high school, I always pronounced this as fog, F-O-G, and this would be fog-o, or something like that. When we have function composition, we have something written in the form f of g of x, which the first thing that we need to do is rewrite this in a form first letter first and put parentheses, g, and then x. So this is our key for translating from function composition form into a form we're more familiar with. And then we see a form like this, we're just going to work from the inside out. So let's work example 1. Let's figure out how this works, and then we'll see if it's that tough. Alright, so f of g of -1. So when we say this, we say f of g of -1. So our first step, translate this. We're going to put it in f of g of -1. And just like anything else, I can't find f of g until I know what g of -1 is first. So we're going to work from the inside out. We're going to find g of -1 first, and then once we found that, we can take that number and plug it in for f. So I'll just do some work over here to the side. G of -1, my g function is 2 times whatever it is. So 2 times -1, which is going to give me -2. So I know g of -1 is -2, so I'm going to substitute for g of -1. I'm going to replace the whole thing because I know that the whole thing is equal to -2. So f of -2. Okay, so I'm going to go my f function, go back to -2. My output value is at 2. So f of -2 equals 2. So we can say overall that f of g of -1 equals 2. And this is the best way to express our answer. So again, when you're given function composition, translate it into something that's a little bit more familiar so we can deal with the stuff on the inside first and work our way out, and then just write your whole answer equals whatever your final answer is and box it in. Okay, so example 2. So this has 3 things. Well, this is no different than the last one. We just need to translate this into a more familiar form first. So we're going to write this as f of g is next, and then of h, and then now we have a variable, so we'll just do h of 0, and then we'll make sure we close our parentheses. So we got a pair here, and another pair, and another pair at the very end, so that they should be about the same size, so that you know what goes with what. So let's say we're doing h of 0 first. If I'm going to do some of this in my head, I know that f of g of, okay, so h of 0 is 0 squared, which is 0. H of 0 equals 0. And then you need to find g of 0, which we just did that in the last problem. No, we didn't. Okay, let's do it again. G of 0 is 2 times 0, which is 0. So then I can say f of 0 is going to give us, okay, go to my f function at 0. We go down to -2 for our output, is -2. So equals
-2. Again, rewrite it first and then work your way from the inside all the way out, because you can't do the outside stuff until you know the inside stuff. You can't do the outside stuff until you know the inside stuff. So work all the way out, and then you can just write your answer. Okay, so here's the slightly harder problems when it comes to function composition. H of g of x. So I'm going to rewrite this. So h of g of x, just like we wrote example 1 and 2. So this time, instead of writing in a number, instead of substituting a number in for g of x, I know that g of x is equal to 2x, right?
And that's what it says at the top of the page. So if g of x is equal to 2x, it says anywhere I have g of x, I could write 2x in its spot. So anywhere I have g of x, I'm just going to write its equation in its location instead. So now I'm finding h of 2x. So if h of x is originally x squared, looks like I'm replacing x with 2x, so I'm replacing this x with 2x. So h of 2x is 2x quantity squared, because everything here is being squared. And when we square something, don't forget we multiply it by itself. So we have 2x times 2x, which is going to give us, let's see, that's 4, 2 times 2, and then x squared. So h of 2x is 4x squared. So then we can say that h of g of x is equal to 4x squared. And here's a little tip. Most of the time, when you have an x as your last of value, as comparing this one as the last couple, if we have an x, a lot of the time we're going to end up with variables in our answer, and that's okay. That's just the way this works. Okay, example 4. G of h of x. So let's rewrite this as g of h of x. And make sure you got right in parentheses, so inside and outside. Okay. So h of x is x squared. Oh, it looks like these are backwards. So we did h of g of x, now we're doing g of h of x. Okay, so h of x is, we know it's x squared, which says we can replace h of x with x squared, we can substitute. So we're doing g of x squared. We know g of x is normally 2x. Looks like we're replacing x with x squared, so we're replacing x with x squared. So g of x squared is 2 times x squared, and 2 times x squared is just 2x squareds. So we can say g of h of x is just 2x squared. Alright folks, you'll have a practice worksheet in the 6.3 folder. Make sure that you come get it. I'm going to scoot this back down real slowly in case you just need to copy anything over one more time. If you have questions, please let me know. Good luck.